Okay, round two. I left the difference quotient up here. We're going to ramp our game up a little bit. All those polynomial functions, like the one we did in class the other day, the one that we just did here in this previous example, those are all pretty standard. They all pretty much act the same way. We just got to be careful with plugging x plus h into the right place, making sure when we have those negative signs that we're subtracting everything that's in the parentheses. We're going to do a couple of different looking ones. The ones we're going to do right now are with a rational function, very simple rational function, 1 over x. If that's f of x, remember that this piece is going to go right here. I need to figure out what's f of x plus h, and I always do this off to the side. This is margin work. You don't even have to include this as part of your problem, right, if you're trying to figure out what f of x plus h is, but this is pretty straightforward, right? Whatever goes in here goes down there. So f of x plus h is just going to put x plus h in the denominator, right? So this goes down there. I don't put the plus h next to the fraction, I put it in the denominator here. So when I go to write this entire thing, I'm going to have 1 over x plus h minus 1 over x. That entire expression is over h, right? So here's my f of x plus h, here's my f of x, and here's my h for this difference quotient. Now, if you look at the previous examples, we always simplify it on the top, but when we were simplifying on the top before, it was always about expanding and then condensing and combining like terms and then canceling with the h on the bottom. Simplifying this takes on a little bit of a different meaning, right? Simplifying this numerator means I've got two fractions, right? This is not simple. If I want it to be more simple, I should combine my fractions together. And in order to get a common denominator, I just ruined it, darn it. In order to combine two fractions, I need a common denominator, right? The fastest way to get a common denominator is to multiply the denominators together. We covered that during our Algebra 2 review at the beginning of the year. But in case you've forgotten, I'm going to ignore the fact that this is in a fraction with h right now, because my main goal is to simplify the numerator, right? To get this to be something simpler. So I'm going to do this. I'll do it in pink over here in a different color. Okay, this is like margin work. This is not necessarily a part of this simplification, but I need to simplify the numerator. I'm going to go off to the side and do that. So I have this denominator here. I'm going to multiply it times the bottom. Whatever I do to the bottom, I have to do to the top. I do the same thing here. I take x, multiply it times the bottom, multiply it times the top. Now when I do that, I am going to multiply my numerators, but I'm going to leave my denominator in that factored form. I'm not actually going to call this x squared plus xh. It's never really a good idea to do that except in one case, which we'll talk about when we need to. That's if these two were conjugates. We would actually do that. That's not happening right now. So I'm just going to leave it as that factored form. Over here, minus, when I do x plus h times 1, I get x plus h. And then on the bottom, I have that. Now, what I'm going to do is I'm going to bring this simplified form back into here. I'm going to erase this, okay, in the interest of saving space. I'm going to write this here. When I do that, okay, the simplified form of this, when I bring this back in here, here's what I'm going to do. I'm actually going to write it as one fraction when I combine these. Now, when I'm subtracting these, take a look. I am subtracting these terms. So what's going to happen? I'm going to have x minus h. And what happens to x minus x? Those are going to cancel. So this entire expression, when I combine it, is going to be negative h over x times x plus h. Okay? I hope this is making sense. I'm trying to conserve as much space as I can here. But when I combine these to create that one fraction, here's my common denominator, but I'm going to subtract this from that. So we get x minus x, they're going to go away, minus h. There's the minus h. This denominator is here, right? And then that is all over h. Now we talked about a shortcut for what to do with this. If you have a fraction in a fraction, where the numerator is a fraction, the denominator is not, there's a shortcut for this. We talked about this in class earlier in the year. Go back and look at your notes. But the shortcut is to take this h and bring it in here. Okay, if I had more room, I'd show you. Maybe I'll just go off to the side real quick. 1/2 divided by 3 is 1/2 divided by 3 over 1, which is 1/2 times 1 over 3, which would be 1/6, which we would get by just taking this and multiplying it times the top. We reviewed that earlier in the year. Now we need it for this algebraic expression. So my new expression says negative h over h x plus h. And when you look at this expression, I have an h in the numerator, and in the denominator I have an h times x times this binomial. So this h is being multiplied by something that's being multiplied by something. So h here is a factor. I know that this h is a part of a sum. I can't cancel this h, but because this h is being multiplied by two other things, it's a part of a product, I can cancel these two h's. As a result, I'm left with negative 1 over x times x plus h, and that is my simplified difference quotient for this rational expression. I have another example from previous years that I'll attach to this playlist as well, showing some of the same characteristics as this one.